Another way to solve a system is by elimination. So in order for elimination to work, you need to have either the x's be opposites or the y's be opposites. So in this case, I have a y and I have a 2y. So the easiest way to use elimination is to multiply the top equation by a negative 2. So you're going to multiply each term by negative 2. So it's going to be negative 4x minus 2y equals negative 8. So I didn't really change the equation. It's still balanced. The coefficients are just different. So now I can add both of these equations, and what's going to happen is my y's are going to eliminate. So I'll have negative x, because 3x minus 4x is negative x, equals negative 7. So this would mean that x equals 7. So just like with substitution, you're going to substitute your x equals 7 back into one of the equations. I'm going to use the first one. So it's going to be 2 times 7 plus y equals 4. So 14 plus y equals 4. So y equals 10, or negative 10. So my solution is going to be 7, negative 10. Okay, example 2. If I just add these up, they won't eliminate. If I add these two up, they don't eliminate. So let's eliminate the x's. So if I eliminate the x's, I already have this be negative 4. So the opposite of negative 4x is 4x. So I could multiply the top all the way through by 2 on each side of the equation. So this would be 4x plus 2y equals 2. Now adding these equations up would give me both the x and the y cancel out. So I'd be left with 0 equals 16. So in this case, 0 doesn't equal 16. This would be a no solution because this is a false statement. So there's no, if you graph these lines, they would not intersect. Okay, number 3. So if I look at this to eliminate, the x's are not opposites, the y's are not opposites. I can't just multiply the top or the bottom by a number. So I'm going to pick one of these to eliminate. I'm going to pick the y's, okay, to talk about first. So these are not opposite, so I want to make them opposite. So what you need to do is find out the least common multiple of 3 and 5. So if you list off the factors or the multiples of 3, you have 3, 6, 9, 12, 15, 18, 21, etc. And if you list out the multiples of 5, you have 5, 10, 15, 20, 25, etc. So the least common multiple of 5 and 3 is going to be 15. So I want to make one of these be positive 15 and the other one be negative 15. It doesn't matter which one you do. So I'm going to multiply the top by 5 and the bottom by negative 3 because then my y's will be opposite. So this will be 30x, I'm multiplying the first one by 5, plus 15y equals 30. And my bottom equation is going to be negative 24x minus 15y equals negative 36. So these two cancels out, and I have 6x equals negative 6, x equals negative 1. So if x equals negative 1, again, I can substitute back into either equation. I'm going to substitute back in the first one. So 6 times negative 1 plus 3y equals 6. So I took this first equation and substituted back negative 1. So then I have negative 6 plus 3y equals 6. Add 6 to each side. So 3y equals 12, y equals 4. So I can write my ordered pair solution. X is negative 1, y is 4. Okay, number 4. So I want my x's to be opposite or my y's to be opposite. The simplest one on this one is I have a 2y. I could make this a negative 2y. So to make it a negative 2y, I'm going to multiply everything through by 2. So I'm going to get 4x minus 2y equals negative 2. So adding these up would give me the y's cancel out, so 7x equals 28, so x would be 4. So now I'm going to substitute back in 2 times 4 minus y equals negative 1. 8 minus y equals negative 1. Subtract 8. Negative y equals negative 9. Y equals 9. So my solution is going to be x is 4, y is 9. And then example 5. So a couple word problems. So when you're doing a word problem, what I try to look for is I want to figure out the variable. So whatever they're asking me for, it's usually found at the end in the form of a question, is going to be my variable. So in this case, there's 2 variables because there's how many children, will that be C, and how many adults, A, are attend. So those are my 2 variables. Then what I do is, because I have 2 equations, or because I have 2 variables, I need to have 2 equations. If you have 3 variables and you're trying to solve for all 3, you're going to need 3 equations. So in this case, I need 2 equations that relate A and C. So C is the number of children, A is the number of adults. So I'm going to go back through and read the problem. The admission fee at a small fair is $1.50 for a child and $4 for an adult. On a certain day, 2,200 people enter the fair and 50/50 is collected, $5,050. So I'm going to have one equation that's relating money. So $1.50 each for a kid. So it's $1.50 per child, and $4 per adult is going to total 50/50. So that's my money equation. The second equation has to do with the number of people. So we have 2,200 people attending. So adults plus children. Actually, I'm going to line up my variables and write that over again. So I'm going to do children's plus adults equals 2020, or 2,200. So I have this system now, these 2 equations. So I'm going to solve by elimination. So I'm going to multiply the bottom one by negative 4, because then my a's will cancel out. So I'll have negative 4c, and then negative 4a, and I'm going to multiply 2,200 times negative 4, and I get negative 8,800. Now adding, so I'm going to cancel out this blue line so it doesn't get confusing. So I now have the black equation and the red equation. So I'm going to add these up. So the a's will cancel out. And then I'm going to add up 1.5 plus negative 4, and I get negative 2.5. C equals negative 8,800 plus 50/50. That's negative 3,750. So I'm going to divide both sides by negative 2.5, and I get 1,500. So there's 1,500 C, so that's children. And then they have to total 2,200. So I'm going to do 2,200 minus 1,500, and that gives me 700 adults. Okay, the second one. Again, just to make it easier to tackle, I'm going to look at my variables first. So how many students can a van carry, and how many students can a bus carry? So I realize I probably shouldn't have put students can a van carry, because this one also reads how many students can a bus carry. So I'm going to change this variable to be V. So I have to relate with buses and vans. So the senior class at High School A and High School B planned separate trips to New York City. The senior class at High School A rented and filled 1 van and 6 buses with 372 students. High School B rented 4 vans and 12 buses with 780 students. Each van and each bus carried the same number of students. So I'm going to have an equation representing high school A and high school B. So high school A rented and filled 1 van and 6 buses. So 1 van plus 6 buses equals 372. Because the V stands for the number of people in the van, and this B stands for how many people in the bus, and this is total people. And then my second equation is going to be 4 vans plus 12 buses equals 780. Now I'm going to use elimination, so I'm going to multiply the top by a -4. So it's going to be -4v minus 24b equals, and now I'm going to multiply 372 times -4, and I get -1488. So adding these two together, these will eliminate. So this will be -12b equals, add those two together, -708, and then divide that by -12. So I get the bus holds 59 students. So I can plug this back in to here and do v plus 6 times 59 equals 372. So 372 minus 6 times 59 is 18. So a bus holds 59 students and a van holds 18.